All right, let's go ahead and get started. Hello, everyone. Welcome to today's Water Cooler Chat, where we talk about all things Livepeer, whether it's delegating, orchestrating, broadcasting, transcoding, or developing. We're here to get some answers and questions, and if you want to join us, we talk about all things Livepeer. And yeah, nothing is off topic. Today we're going to be doing just a regular Water Cooler Chat, so we can go through introductions and topics, and yeah, go through them together. So I'll start with myself. I'm Titan, been running the Titan Node Orchestrator since April 2020. And today my topic is around, well, I've got two topics, but I'll just pick the one, something I'm just working on, which is lens posting on lens protocol. I'm trying to post a live stream onto lens, and I'm dealing with typed data. I don't know how typed data works for posting onto the blockchains, but they require typed data, which I need help with. So if anyone has any experience with that, please let me know. Great. And we'll move on. Chase Media, would you like to introduce yourself and a topic?
Hi everyone, it's Chase Media here. I've been running the node since, just about a year now, and I do not have any topics today, just chiming in to say hi to everyone. Thank you.
Very good. Thank you for joining us. Zorro, would you like to introduce yourself and a topic?
Hi everyone, my name is Zoro. I'm a member of the Pixel Fields team. Been running it for like 6 months now. No specific topic today, just listening in. Thank you.
Very cool. Thank you for joining us. Transmental, would you like to introduce yourself and a topic?
Hi, my name's Zach. Building Xenon. No real serious topic to go through. Maybe Ben and I could get into some VOD stuff from what we were talking about yesterday in the orchestrator chat, but for the most part, just listening in.
Very cool. Thank you for joining us. Frank, would you like to introduce yourself and a topic?
Hi, yeah, I'm Frank. I'm running Ultima Ratio node since 2 years now, and I have no particular topics tonight. Thank you.
Very cool. Thank you for joining us. Mamood, would you like to introduce yourself and a topic?
Hey guys, my name is Mamood. I run the cluster orchestrator for almost a month now. I'm based out of London. I don't have a particular topic, just like a call out that I'm working on trying out Livepeer with like a few different frameworks. So one thing is I'm trying to like play around with Livepeer and integrating in like a no-code tool like I don't know if you've heard of it. It's called Bubble. And the other thing is also trying to use Livepeer with Flutter. So those are things I'm working on. No particular questions as of now, but just a call out.
Very cool. I like both those things. I'm not experienced with Flutter, but I have used Bubble in the past, so I'm really curious about that development. So very cool. And as always, thank you for joining us, Mamood. Ben, would you like to introduce yourself and a topic?
Hey everyone, Ben with Authority Null. Been running my node for over a year now and been working on the video miner pool as well. No topics here today.
Very cool. Thank you so much for joining us. Mike Zuper, would you like to introduce yourself and a topic?
Hey guys, Mike. I run the Zodap orchestrator for also over a year, and I'm also a member of the video miner pool. As far as topics, I always, as you guys know, I'm trying to talk about broadcasters and media servers. So I wonder, if we will get to a point where we take the Livepeer Smart Contracts and use other media servers to interact with the blockchain and, start finding other ways of getting demand on the network. So that's where my headspace is. And, if we have any discussions on it, I'm, open for it, but not really a question or a topic per se to dive into unless we want to.
Well, that's a really interesting topic because actually Mamood has a grant forward for integration with Bubble, and so one argument you could say is do we want to include smart contracts for Bubble specifically so they can interact directly with the blockchain rather than going through Livepeer Inc., right? Which is is that kind of what you're saying?
Yeah, I mean, the studio is a way, running your own node and a broadcaster is a way, but I feel like taking an existing media server and then allowing it to interact with the blockchain in the Livepeer protocol, calling, sending out tickets and, all of those things that the broadcaster does today, but do it, from a different media server. So it's similar, but slightly different.
Well, I like the topic, and we should definitely dive into it. So, thank you for joining us, Mike Zuper. Pon, would you like to introduce yourself and a topic?
Good evening, everyone. I'm Pon. I've been running Pon Node for nearly a year now. I have no specific topic today, just listening in. Cheers.
Very good. Thank you for joining us. Speedy Bird, would you like to introduce yourself and a topic?
Hey, Speedy Bird. I've been here for a few months now. I don't have anything really pressing. I mean, I have noticed, and I don't know if this is me or the Telegram bot, but I've got the setup too where, it'll tell you whether or not your system's called for rewards. And occasionally, every now and then, I have it complaining, and I see no particular issue with the system that's supposed to call rewards. So I didn't know if maybe it's just a timing issue where the bot is maybe catching up on events on the chain and it's not giving the system a chance to call rewards or not. Anyway, if anyone has any thoughts on that, certainly that will be the only topic I have.
Very cool. Yeah, I think I've seen that in the past, so we'll definitely jump into that topic a bit later. So thank you for joining us. Just to clarify the issue, your node is calling rewards successfully, but the Telegram bot sends you a notification that it hasn't, and then likely, in my head, it would send it again later saying you did.
It does say later I did. I found that when it is saying it hasn't called it, I go in and I call it manually, but it's not like consistent, right? I mean, the time that it gets called, and maybe this is like RTFM problem for error between user and keyboard, but I assume that the system calls rewards on a recurring basis that's at a set time based on when you maybe started your node, and it should be consistently doing it at that same time every day. And I don't know what rules the Telegram bot has, if it's like looking at drift, like, hey, you haven't called rewards, and then the clock's running down on the number of blocks in the current round, or if it's, hey, the bot's only checking at a certain time, and so it's causing kind of
Time before the round ends.
false negatives, like warning me about something, well, that would normally happen at a scheduled interval that's acceptable, and I can ignore it as background noise, versus, hey, yeah, there is really an issue. For some reason, I haven't called rewards. I need to call it manually here because whatever components on the cycle calling rewards isn't really smart enough or is having some kind of problem, which I don't really see in the logs. That was a lot.
Yeah, no, that's fine. That's fine. I've run into this issue in the past. That's why I use the better reward call script by Marco, and that eliminates that.
Okay.
So I would recommend setting that up just as it gets rid of all your fears of calling reward and all errors and everything else.
Yeah, I mean, it's not like I'm seeing errors. I'm just, wondering why I'm getting this some days, in the middle of the night, and some days not at all. Like, and it calls rewards maybe later in the day, but it seems like maybe I'm getting these alerts prematurely. I don't know.
I feel like, so I think the Telegram bot, like, as soon as the round initializes, the Telegram bot checks, like, maybe just a few blocks after the round is initialized or something. And if you're not called by then, it'll send you a notification pretty soon. I don't know. You'd have to. Oh, Varys is here, actually.
We got Varys here. I was going to say.
Yeah, I didn't see him pop in.
On the bot. Yeah, yeah.
Yeah, hi all. So how it works is it like as soon as a new round starts, it like defaults the reward call called status of all orchestrators to false. And then it like regularly checks if there are events on the blockchain, and it checks about all 2 hours, which is like 500 or so mainnet blocks. So if you have not called reward in a new round after first 500 blocks, you will get the notification. Like the orchestrator did not yet call the reward. So I'm not sure if there are any bugs with that. I haven't personally like seen any, but if there are, yeah, just like happy to talk about it and potentially fix it.
So is there no threshold that it says, I'm going to wait until this percentage of blocks remain or this predicted number of hours left in the round are occurring before I start warning you? It's just immediately after the first 500 blocks? You haven't called it?
Yeah, it starts warning then, because it's usually
Okay.
like, I mean, you have 24 hours to do the reward call, right? So
Yep.
it starts warning 2 hours into the new round. And then afterwards, it just keeps warning you every 2 hours or so that you did not yet called. And I think it also tells you like how many blocks there are remaining
Yeah.
within the round.
The errors I've been getting lately are usually about 5 hours into the round. So around 2,500 blocks, and then from there on it starts complaining. It sounds like it's slightly different behavior than what you're describing.
And Speedy, your reward has already been called, and it's saying it's not. Just to
No.
clarify.
I mean, it's accurately saying the rewards have not been called. It is correct.
Because they should be getting called if you have it set to automatic right when the new round starts. So
Okay.
there may be some issue with your setup, and it's not the same, and it's not the same time every day because there are 19-hour rounds.
Right.
So that
Yeah,
changes.
it's just based on block number, right? So I mean, that can vary.
Right. So I'm just so it's accurately telling you haven't called the reward. So I guess
Yeah,
we need to
it
figure
seems
out
like it's
why you're.
waiting far later than what Barry's is saying, but it's still based on the way it's designed, as just explained. I should be getting these alerts far sooner. For some reason, I'm getting them later, and that might just be the systems that is running this is catching up and didn't. I don't know, but anyway, I'll see why my system's not calling within the first round or first 500, first hour. Right? That sounds like what it should be doing. Within the first hour, it should have called rewards.
Because it varies. I mean, if you have like your reward set to automatic or just it calls like basically right when the round starts, right?
Yeah,
I'm not talking
exactly.
about the bot, just Livepeer in general.
Yeah, usually it just does it like within the first 30 blocks or so, I think. And so 500 is quite a large threshold already. But Speedybird, you're only getting a warning, or like you're getting the first warning like 2,500 blocks into the round. You're not getting like a warning after the first 500?
Correct. So last night I got warnings at block 2716, and then the last time this happened was February 26th, and it was at block 2710. So this isn't a daily occurrence. And then the one before that was February 18th at block 2728. So it's somewhere around that 5 hour mark.
All right, I'll definitely look into that. I think it should warn you sooner. I haven't personally gotten like
Yeah, I've
a
had the
warning
same
for a
thing.
while, so I'll definitely look into that.
Speedy
You're
Bird.
It
getting
happened actually the first time it happened to me was this weekend, and it was at 2715 block. I didn't get any other notifications at all. The funny thing is I logged into my node and I went to manually call reward, and it threw a 500 error in my log. I actually had to shut down my Livepeer node and restart it, and then I was able to claim reward. But in terms of the notification, it was at 2715 block when I got my notification. And it was the first time this has ever happened to me.
I would highly recommend using the better call reward script. I put it in the chat there, pinged you for it.
Thank you. I will certainly take a look at it.
yeah, as soon as I started running it, it like eliminated all my problems with calling reward, and it's been running for, I think we're at 7 months without ever touching the machine, and I've never gotten a notification saying I missed a reward call or anything. So
Cool. Well, I'll take a look at it. Thank you.
yeah, it's a pretty simple script. It literally just, it's a Python script, and it just looks to see if you've called, and if he hasn't, it just it asks your node to call it, and I think it
Oh, this
checks.
runs in a container too.
What's that? Sorry.
It looks like it's running in a container as well.
Docker, yes, sir. I've been too lazy to get it set up myself, but I know Marco spent some time on it. I just haven't. I know quite a few folks use it.
It's a Docker image?
Yeah, he created one for it.
Oh, maybe this is not the one. I just have the Python one, so
Kind of defeats the purpose of having having a node running specifically for calling rewards.
No,
That's
it just,
right. It's a replacement
no, it's not a
Yeah.
replace. Oh, is the Docker one a replacement?
for the secure. No, he's talking about a secure O. Like if you're running a secure O just to call rewards that has your private key that's not on the network, like he's using that to call rewards, and that's how a lot of people were set up. But you're saying is if you run that Python script, you really don't need to run a secure O that doesn't take work.
Yeah.
No. This
You
Python
do.
script, this Python script doesn't replace your O. It
Oh,
sits
it's
on top of
calling
your
the
O.
CLI.
Yeah.
It's
No.
calling the CLI.
It literally
Oh,
just
I see.
you. So my node is on a secure machine, completely locked down, and it's just a Python script that goes, "Hey, did you call yet?" And if you didn't, it just calls the CLI and calls it for you. Calls like 11.
Yeah.
Yeah.
Okay.
It
All
doesn't.
right.
It does what
Doesn't
you would
replace
manually
it.
do, which is you log in, you open up the CLI, you press 11, and you call reward. It just does that for you.
Oh, you run it
Okay.
on the O. Okay, but what the hell's the point of the Docker?
You run them both together in a stack, and then you can basically still keep it managed by container, and then
You can tell that you can run it as a container and pass it a flag that points to your other containers.
that's right. That's right.
No thanks.
Did you say no thanks?
Yeah, no thanks.
It's just-
7935 is not going to be open, so no thanks.
No,
I'll run this script
Well, no,
on
that's why you run it in a Docker stack,
no.
because you put
Okay, why would you
the
run Docker?
O and
Wait.
the.
What? I don't see.
No. I'm not
That's
saying
what
don't
he
run
runs.
Docker. I'm saying you run this script in the secure orchestrator container. Don't run a separate container with this service that connects to your secure orchestrator, because then you have to
Oh, I see.
expose 7935. So it's Titan saying run the Python script directly on your O. You don't need another Docker container to do this. Otherwise, you're opening up ports that you don't need to open up.
No, and that's what I'm saying is that's why that's not true. If you run the Docker node and the Docker Python script in a private, they're on private networks where you do not expose the host port, you will be able to do it in a secure way. And in fact, that's what I plan on doing. But to your point is, like, if you just embed it into the Livepeer Docker image, then yeah, that's much easier.
Well, actually, what you're saying is preferable, because if it's in another container on a private network with the secure O, you're not opening ports to the outside world, or even
Still locked down. That's
still locked
right.
down, and you're guaranteed that this better call rewards script, if it ever has a problem and it crashes,
It's your backup.
the container will restart and start the service up again, so you don't have to worry about monitoring it. Well, you still want to probably monitor, but you don't necessarily need to worry about it going down willy-nilly. It's going to self-recover and self-heal that way.
That's right. Yep.
Yeah. Got it.
And I'd like to add a bit of advice. So we do run our own Arbitrum node, and I've found that that's a lot more reliable with calling reward than if you use like a hosted service. I mean, usually if I ever have to fail over to a hosted service for a while, like Alchemy, almost every time I have trouble calling reward. It might just be me, but.
Wow, really? That's weird.
I've found that as well.
Yeah, I mean, anytime you're running a third-party service, if it goes down, you're likely. That's the thing that's going to be hard to debug here. Where, where's potential network failure on a service, and is it being logged or not? That's a good point.
But yeah, you just run the Python script on your O machine, and it just listens to the port and calls it if it's not there. So so if you have a more unreliable RPC endpoint, then you can just run that. I don't know. Anyway, it's a good idea if you're having problems with it calling reward at the beginning of each round. So I'd highly recommend it.
Yeah. Thanks for all the help.
Staking is the critical part to us being orchestrators, right? Especially if you got delegators. So, it's critical to make sure you call those rewards because, that's basically leaving money on the table for your delegators.
Yeah.
Yeah, I mean, in general, like I'm not saying anything bad about this Telegram bot. It's perfect. I mean, if it weren't for Telegram bot, I'd have to rely on, a different monitoring infrastructure. So this is great. I wouldn't have necessarily caught on to the fact that rewards weren't getting called if it weren't for that. Although that just speaks to Speedy's got some work to do on some instrumentation.
Bada boom. Cool. All right. I think we covered
that was one
that
hell of an
topic.
introduction. That was one hell of an introduction.
Yeah, which is fine. I promoted the discussion because it was relevant. Varies is right here. Cool. Anyway, thank you for joining us, Speedy Bird, as always. Varies, would you like to introduce yourself and a topic?
Hey all. I've been running the Where's Numeris.eth orchestrator since 4 years now, and no specific topic from my side.
Very cool. Thank you for joining us. Troy, would you like to introduce yourself and a topic?
Hey guys, how you doing? I don't have any specific topic, but I'm building Xenon with Transmental, Owens as we call him affectionately inside. I'm kind of just more here for the vibes. And I do actually have a question if you guys have been running into the same thing where on the Explorer page, if you guys have noticed like the PFP for the specific orchestrator has been like dropping on you. And I was curious. It was like, what are you guys referencing in the ENS? Because I switched it off of using like the NFT link, and then we switched it to the IPFS link, and now it goes down every like couple hours, and this is just driving me absolutely insane because I'll wake up and I'll be fine, and then like an hour later it's gone. And I'm like, what's
Something's wrong with Explorer.
It's a Livepeer thing. It's not really something you can.
They haven't been putting a lot of effort into Explorer lately, and they were talking about putting some caching in to deal with things like that, so that if they can't pull the data, because there's some, I guess, downstream APIs that go down a lot. But okay. I think we all experience.
It's not just me.
No.
We call the dogs off. No need to lose any more sleep. You're good.
No, it bothers me when I see my broken one too, and I just saw when I saw it today. Then I did something, and I came back, and it was there, and I was like, okay, whatever. I guess that's just life. But yeah, it sucks.
The gerbils are taking a break on their hamster wheel, so just relax. Everything's good.
Actually, I was also curious about, John, you were saying you run your own Arbitrum node. So like you're just indexing all of Arbitrum and then you're doing that locally? Is that what's going on?
Yeah.
So using Alchemy?
Yeah. So we run Arbitrum Nitro in Docker, and we've also got Geth running as well. So we have a dedicated system that runs Geth and Arbitrum together. But you can run basically just an Arbitrum Nitro node off of a ETH L1 endpoint from Alchemy, and I think in general you'll get a little bit better performance that way. It's not a fully decentralized proof solution. You probably want to run your own Geth client to do all of that, but I think you'll get a little better performance out of just the Arbitrum part if you run your own local node. So that's how we have it in our network. We have like 3 servers, and one of those servers is dedicated to blockchain.
When you say better performance, what do you mean by that? Or like, what's it like?
Yeah, I mean, some of it's like superstition, but I mean, I really think I've seen it. There, you can imagine if there is a delay in response time from the getting blocks or any of those RPC calls to Arbitrum, that it could potentially at least, maybe some blocking on orchestrator, or cause a little latency or memory increase, or maybe even IO wait. Like there's probably just a little impact there potentially.
So you're saying, at least in theory, that when you say better performance, you mean better performance for Livepeer?
Yeah. Yeah.
Got it.
As we're running everything, locally. It's pretty reliable. It's kind of over provisioned as far as system resources, and it never has any issues unless something going on. But it's a trade-off between
looking at
having...
your public dashboard, you may be onto something, because I definitely noticed that you tend to have a very stable, reliable, high stream count. Yeah, you might be onto something.
That's a good observation. I took the tip from really Varies when I joined years ago. Was a year or two ago. When I heard he ran his own Geth node before we even made the Arbitrum migration, I thought, well, not only is that a really good idea, but that might even have a performance, benefit.
Just remind the folks, John, that running Geth and Arbitrum's no piece of cake. You got to stay on top of that stuff. There's a lot of work involved there, and if you don't know what you're doing, boy, you could have a whole lot of outages.
Yeah, we had a lot of trouble initially when the merge happened. Everything ran pretty good from July to September, and then after the merge, we had to launch a consensus client, and then we were running Nimbus at the time, and between running Nimbus, Geth, and Arbitrum within our local network, it was crashing our router constantly. So we're currently Nimbus is our consensus client, and it runs on DigitalOcean.
Oh, you run your consensus client in the cloud.
Yeah. It kind of, because it just deals with that network component. Apparently, the consensus client pulls a lot more data than the execution clients do.
Oh, is that right?
Yes, sir. I got booted off of Hetzner for all the activity my consensus client was doing.
There is a setup, I guess all of them are different, but there is a configuration, I think it's called ENR, where it tries to automatically discover its public IP. And you can either statically set that so it doesn't do it all the time. I saw some setting that they recommended if you're running it in a data center to set, but that was for Nimbus. But I can post my configs sometime.
Just caution those who go headlong into running ARB nodes. It's just, be prepared for a deep rabbit hole.
That's true. There's an update, software update. Some of those have to be done that day, or else everything goes down. And then,
yep,
if
that
you have
happened
it
to me
turned
too.
off, if we turn our stuff off for more than 30 minutes, it'll take 2 hours to get caught back up on the chains. So.
Oh, really?
It's a bit of a trade-off.
So what do you do then? You just switch to a public RPC for that time?
Yeah, actually, we still use the proxy D script that Ben had found a while back, and we've got Alchemy hooked up on that locally, so kind of local load balance on the transcoder. And
that's working for you?
I was going to say, you actually got it to work, huh?
Yeah, well, what I do is I manually fail it over using the host file. So we've got an IP address for that, and then an IP address for our own ARB node, and the context path is the same. So I would just update the IP from localhost to our hosted one, or back to localhost for our backup proxy D.
Oh, the days of troubleshooting Arbitrum. We wrote Cloudflare proxies for that stuff. We run our own nodes. Oh my God, there were so many things that we had put out there for keeping stability, because you're right, in September or August, around that time period, it was a disaster for Arbitrum. There were so many outages, but it's, knock on wood, it's been pretty good.
Yeah. Just to remind people, if anyone wants a more custom solution that they don't have to run themselves, there are a couple of community members who do run a service. FTK has the community node, and Zoop has something as well.
Yeah,
and a lot of docs on how to produce a high available environment from grants that Ben and I wrote. So there's definitely a lot of options if you're curious.
I just blindly use the community ARB node by Forkoonsman, and when it goes down, I just go, looks like I'm down.
I think it'd be good to have at some point I could write up a guide on how I put all this together and tested it, and then even broadcasters or anyone could find it maybe useful to set up their own setup, add a little more decentralization.
Yeah, I have some notes and docs that I wrote as well. If you're willing to, we can compare some notes and get something out there if you're interested.
That would be awesome.
That's a grant, guys.
I
Collect
love
that
the idea. I like working not for free. But yeah, and it's all in Docker what I've got, so it probably would fit really well with your notes.
They call me Mike Docker Zuper.
I thought they call you Tidal Wave.
They call me Tidal Wave Mike Docker Zuper.
I think the list just gonna keep on going.
Well, it depends on what you call me, Pon. I hope this is a public place, so be nice.
No, I
It was
can't tell
it's
it's a
nice and
public
short in
place.
that case. Don't worry.
Like everyone's chiming in now. They should jump on it. Come on, let's go.
Mike broke the ice.
All right.
Good.
That was
Who else we gotta introduce?
we got two more
Troy,
people to
thanks.
go through. So I will. Troy, thank you so much for your introduction. This is it was a great introduction, and yeah, there we go. Okay,
It was a pleasure.
very good. Papa Bear, would you like to introduce yourself and a topic?
Sure. I am Papa Bear, and I've been running my orchestrator since about 18 months now. And I'm really just here hanging out today. No specific issues or topics.
Very cool. Thank you for joining us. John, would you like to introduce yourself and a topic?
Well, hey, my name's John with Leet Encoder. I've been running the orchestrator for about a year and a half now, and no specific topics today other than what we already covered. I'm looking forward to talking about maybe even some broadcasting stuff if anyone has any questions or brainstorming on that.
Very cool. Thank you so much for joining us, John. Oh, and that reminds me, I do have another topic. My topic was about the Livepeer Router and the testing that's going on with that. So I'd like to provide a bit of an update and maybe get some feedback from the community on interest and stuff.
I want to hear about that. Good. I'm glad you brought that up.
Very good. Yeah, it's been an interesting journey so far, and big shout out to Brad, who's in the audience for writing it, and then also going through the process with me of me trying to break every component of it and him running around trying to fix it. So it's been a good duo, and Elite being there, of course, providing feedback. So it's been a good chat. This chat, some days it goes on like pretty crazy. It's just like hard to keep up. So it's a fun little process building something from scratch. But I see Ryan has joined us. Ryan, would you like to introduce yourself and a topic?
Hi, my name is Ryan. Yes.
Yeah, we can hear you.
There we go. Yeah, name's Ryan. I've been doing this for about a year and a half or so. I have no topic. I'm just here to listen, though. Thank you. Part of the Video Miner team as well.
Very cool. Thank you for joining us, Ryan, as always. Okay, cool. Well, yeah, we got some topics to go through. We finished introductions, which took us 35 minutes. So that's very, very cool. But I would like to jump into, I guess, my topic real quick about the Livepeer Router, if we want to talk about that real quick. So, does anyone know? Is anyone not know what the Livepeer Router is? I've mentioned it in the past. Is everyone familiar what it's trying to achieve?
If you want to refresh me, that'd be great.
Cool. So, the problem in the past was when I joined Livepeer, we were all using one IP address, and pretty much every orchestrator just had one location. Nico wrote out and said, "Hey, and Nico was building Livepool, and he actually had 3 orchestrators. He had an orchestrator EU, orchestrator North America, orchestrator Asia. That's how he was going to have different endpoints, and it was really weird because he had different stakes for different regions, and he was still, and so he put a bounty out saying, can someone figure out how to do GeoDNS so I can just use one endpoint for all my areas?" And I said, sure. So I wrote this this forum post on how to geolocate with Route 53. And I believe now everyone in some fashion has some version of geo routing, latency routing, or something where you don't have just one endpoint, but you have many endpoints. So that was a nice little band-aid solution to the problem. And it's worked quite well up until, It's worked really well, and up until now, it's worked decently. But what I've run into is, at least with Route 53, I'm not sure about Cloudflare and all these things, it's pretty limited on the latency routing. So like, unless you're using Amazon servers, they can't actually very well determine how far you are from where a broadcaster is. So they kind of just guess where, how far you would be, and guess which one would be the fastest route. So right now I'm using actually GeoDNS, which is like based on borders, so it has nothing to do with performance. So like, California goes to California, and New York goes to New York, and Germany goes to Frankfurt. So like, I have all these rules set up where I'm like guessing where nodes should go based on borders, which also doesn't really make any sense. So what I decided, what I proposed was this idea of this router, which I think was originally proposed by Yondon, which is the get broadcaster request goes to some sort of like master router, and then from there all your nodes ping the broadcaster to see who's the closest, and the closest as in fastest latency response, so it's a ping. The fastest one then gets chosen as who the broadcaster should go to. And the idea would then, you'd have just complete global coverage of the absolute fastest node all the time. And we could eliminate the need for third-party services that do domain stuff. So, Amazon, Cloudflare, we can just completely eliminate that. So that's the idea behind the router. Does anyone have any questions around that so far?
Yeah, I agree with you 100%.
Cool.
So what Brad has written is this script where so I came up with this idea of master and slave router. He just said, listen, all routers are all alike and they all just communicate with each other. So there's no, but I use the word master in the sense that that's the one listed on chain as your service URI. Okay. So any one of these nodes, any one of these routers can get pinged and it'll return a response. But for the sake of how I'm explaining things, master is the one that is listed on chain. So what happens is,
Can I jump in with a question really quick?
Yeah.
Last week you mentioned that if what you were calling the master router at the time went down, that you lost service on all of them. Is that still the case, or is that
so
no longer an issue?
If your service URI points to one IP address, then if the master router on that IP address goes down, then it's not hitting anything, right?
Right, because of the I don't know how to use the right terms, but yeah, if that thing's not reachable, then
yeah,
then
if
does not the other ones.
Yeah, if the router goes down that it's trying to hit, it would not return. Now you can fix that quite simply with failovers. So if you have, so now you can use some sort of custom thing that you want to make, like Nginx or whatever, to like failover, or you can use something like Amazon and Cloudflare, of course, to do failovers. So you would just have that ping the router check the port of the router every 5 minutes or whatever, how long, I don't know, every second. And if it goes down, you could easily point it to a different router and it will return the exact same results. So yeah, the failover is actually quite high. You could fail over to every single one of your routers and until the very last one. So you could have a really good failover system for that.
Yeah, that makes sense, because I was on part of the call when you were first working on it with the guys, and I thought I remember it being that it doesn't matter, like there really is not a master router, so to speak, but now I understand exactly why.
I should say it's the first router, because you
can now I understand why you're using that term, and I get it now. So yeah, thank you.
Because okay, so the terminology. So I'm going to explain what we've been working on because we're running into issues, and so we originally tested. I tested a master router in New York with 2 other routers in Toronto and Los Angeles. So just 3 locations on Livepeer Academy. And it worked really great. Like it was like every time it hit the New York node, it would send out a ping request to Toronto, LA. They would both return their results, including New York. So all 3 would return their results. The fastest one then got cached. And for the next 5 minutes, anytime that same IP address came in and asked, it wouldn't even re-ask for a ping. It would just send the result that was cached. Now you can adjust that from 5 minutes to a day or however long you want. And when it's cached, it's returning the get orchestrator request in sub 1 millisecond. So like if it's cached, then you're getting really good response time. So the broadcaster is not concerned. Like if it's cached, it works really great. Okay, so that was working really well. Then I added all 7 orchestrators. So Singapore, Sao, Sao Paulo, Frankfurt, London, all the ones. What was happening here was a ping request would come into New York. It would send out a request to Singapore and Sao Paulo. But there's 200 milliseconds for the request to get to Singapore. Then Singapore has to send a ping to the server that could be back in New York. So that's another 200. Then it has to return that ping, and then it has to send it back. Has to send that data back from Singapore to New York again. Okay, so you're kind of bouncing around quite a bit. So now we're up to about a second for the master O to receive the information. And it would do this based on anywhere that it was getting pinged from. So, so to add more insult to injury, if the ping was coming from Frankfurt, it's pinging New York. New York's asking Singapore to ping Frankfurt, then to come back. Anyway, the whole round trip ends up being about a second. And then the broadcaster also has to include the time it took to get from Frankfurt to New York. So you're looking at about a 1.5 seconds response, okay? Which turns out to be fine, especially if you have a 2-second, because I think the broadcaster discovery, apparently the broadcaster discovery timeout is 4 seconds, okay? Now, if you can imagine though, you're competing against people that are literally responding within like 10 milliseconds, right? So you're getting back in like 1.2 seconds. So I'm trying to figure out if this is affecting my selection algorithm and how much work I would get, okay? But on top of that, what would happen was Sao Paulo, just the connectivity, if you imagine, sometimes, I don't know if you've ever pinged something, sometimes like it just randomly comes back with a much larger delay, or there's something. So what's happening was the timeout set was 2.5 seconds that the master router would give up on the slave router and say, hey, you didn't return a response, I'm not even going to wait any longer. For some reason, Sao Paulo quite regularly would be just timing out. So now, if on the New York node, if the New York node got a New York ping, it wouldn't return till like just over 2.5 seconds because it's waiting for the Sao Paulo node to ping that node and get a response. That was causing problems, and I was very confused as to what was going on. But on the stream test, it was very sporadic on what streams got through. And what would happen is I think it would do the first 4 segments, and then it would drop it because it took 2.5 seconds to respond. I don't know. So anyway, this is where we're at. I'm trying to figure out if it'll work if the response is under a second, and whether that would actually hinder the selection process of how much work you get. So that's my first test, is to see if you return something in 1 second, will you get penalized or not? Because if you don't, then you could just reduce the timeout to 1 second and say, hey, Singapore, if you don't get back to me in 1 second, forget you. I'm not even going to bother, right?
Can you run a master on each node?
Yes.
Yes.
Would that eliminate the delay?
No, because every
No,
node
because every
still has
node
to
still.
ask every other node. So
Oh,
So
if I set up a geo routing and throw one master node, it's just a node, it's just a router. If a broadcaster pings my Singapore node, it still has to ask LA, New York, all these other ones to ping and
It's
wait
got to
for that
find out which one's the
response.
best, which one's the fastest. So
Yeah.
it's got to ask them all.
Yeah.
I
So-
wonder if there's something you could add that if it pings it and gets a response that is low enough, it just doesn't ping the other ones.
Yeah, that would be a
Yeah, that
timeout
would be a
where it
timeout.
just sends out a request, and if you don't get back fast enough, it just forgets you.
Yeah, so what you're facing is a classic problem in distributed systems. So whenever you're designing a distributed system, you shouldn't make any assumptions on requests succeeding or any any timely responses. It's going to be very sporadic. It's one of the classic situations with any decentralized system. What I would do is I would just put a time window, which I think is again, we could say like a second. And then the fastest response I get within that second is going to be my pick.
Why not make it the first one to respond?
Okay,
I
so
mean,
here's an example of why that wouldn't work. Let's assume.
I'm sure there is.
Okay, so let's assume that. Okay, here we'll make this even more complicated. Okay, let's assume the ping, the broadcaster originates from Singapore, but the master router I have listed in New York. So what happens is the Singapore request comes in, hits New York. New York then has to ping the Singapore broadcaster node, but it also has to send a ping to Singapore to ask it to ping the node and then return. So technically, New York will get a faster response because it doesn't have to wait for Singapore to do the ping. But Singapore is in fact right on top of it, it's right near it. So it'll have the fastest response. But it won't receive that fastest response
I see what you're saying.
until it sends it back to the master router, right? So the problem lies with it seems to me it's a roughly 200 milliseconds no matter where you go in the world, between my nodes at least. So
when you're talking about like a master, the role of the master node is to basically be like the receptionist, right? Like the
yes.
first one to get any response. And you can identify the origin of the requesting node, right?
Say it again.
Like you should at the master router, you should be able to identify where the request is coming from which region.
That's correct. Well, yeah, you can see what IP address it comes from.
So in that case, why don't you have like at the master node like a periodic task that runs and see which nodes are up and in which regions, and whenever you get the request, you don't have to ping all the nodes from all the regions. You just pick up the highest one that you have from the last.
Well, yeah, it caches. Like once you do it once, like let's assume it caches. So let's say Mamood is an IP address. You send me a request. I send all my nodes to ping you to see who's the closest. I save that result so that the next time you request, I don't ask all the other routers. I just send you the response, and that seems to work really well.
What I'm saying here is it shouldn't work based on the broadcaster request. You as a master node, you should have like sort of segment all the nodes geographically. So let's say you have like a table of, well, Mamood cluster is in London, and I don't know, Ben authority null is in somewhere else, and so on. And then whenever you get a request, you just try to match it at the master router to the closest node.
But how do I
And
know
just
where that request is coming from?
you just said you have the IP address.
Yeah, but okay, so what does that IP address give me as information that would make sure that I have the fastest node?
Well, you don't need the fastest. You just need one that is close enough. Like if let's say you have,
But no,
let's say you have
just because you're
Mhm.
close latitude, longitude doesn't mean you're fast.
That's also true. But in this case, you will also not guarantee it even if you do the ping. Because the network conditions change over time. So even if at the time of the ping you get the fastest response, that also doesn't guarantee that it will be the fastest throughout. So I guess your bet is still to get geographical proximity. Like that would, I think, on empirically would be pretty much your best bet.
Which
So
would
you're
defeat
suggesting
being able to run it just on this router, not being reliant on a centralized service that was the original reason that Titan wants to run this. Is that right, Titan?
Right. Well, then the other question is, I have their IP address, but I would have to use some third-party database to probably look up where and what latitude, longitude that IP address is. Whereas if we want to be, Livepeer, a decentralized open source network, we probably don't want to have to rely on any third-party service. So
You don't need to have a third party service. What you can do is again something it's you can have a consensus algorithm on who's the master. And that master can change if the main master fails, for example. Then you do it's like a voting mechanism between the nodes, and then what do you call promote a new master node. So it's still a decentralized system. It's just that it has a master, and the master is the one that keeps track of the database. I can send you a few algorithms on how to do that, or I can maybe spend some time and implement it myself.
Sure. But what if you assign an IP address that is geographically closest, but there would be a firewall in the way? Like maybe I've got an orchestrator in Japan, and the broadcaster request originates from China. My Hong Kong one is maybe further, but there is no firewall in the way. So how would I make the assumption that it should go to the closest one and not the one that has the fastest latency response?
So you're assuming that there is something that blocks the request if the broadcaster requests it, but it wouldn't block it if the master requests it. Because at the end of the day, the master runs a periodic task to check all the nodes.
Check which nodes?
If it's all the nodes all the orchestrator nodes.
Yeah, that makes sense. At the very least, the router could do that on a regular basis. Just make sure that those nodes are up.
Yeah,
And then,
because you need to keep it updated. Like we can run it every, I don't know, 1 minute, 5 minutes, and you can experiment with it. But at the end of the day, the assumption is if the master node is able to reach it, then the broadcaster should be able to reach it. And if the broadcaster fails for any reason, it can request a new one, which again, the master can just go to the next in the database that's available.
I think there are some databases available that map IP addresses, like something with the numbering pattern, right?
Yeah,
geographically.
There will be plenty.
Yeah. So are we saying that latency in this isn't the biggest factor? In fact, that it's proximity?
So what affects the latency is a lot of things. It's not necessarily like again there isn't like a one thing that you can programmatically have. Even when you say I'm gonna ping and see what is the fastest response, it's not gonna guarantee the fastest response throughout. It might be at this particular point in time, it is the fastest. It's basically like traffic. You just cannot. It's an inherent part of a network. So even when you do it at the time of establishing a connection, even if you identify the fastest, it doesn't mean that it is actually the fastest. It's just the fastest response at that particular point in time. So the proximity is, I think, empirically is a good enough approximation.
But wouldn't you say that the latency is also a good enough approximation? Like the distances we're mainly dealing with are continental, right? Like
Yeah.
if one, or if I have a broadcaster node that sends out a request in the middle of the United States, and if it ends up on Los Angeles or Toronto, or it's really not going to have any effect. But if I get a response from South America, I'm not going to want it to land in New York. So that would be pretty easy to detect through a ping test, right?
Yeah, I mean, yeah, that's also true. The thing is, I think you would be, if you do it the way I'm proposing, you would save up the time of requesting, like requesting first from the master and then doing that request again. And you will always have, like, it's an inherent problem. You will always have some sporadic behavior, like where something doesn't respond or whatever. There
Right.
isn't right or wrong really in that case. So what I would do is just as a good practice whenever you're designing a decentralized system is that you need to have timeouts. That's maybe like the short version. You need to have a timeout. If you need to get to pick the choices within a specific time frame. You cannot just let it be or expect everybody to respond within time.
I mean, from what I'm understanding, it doesn't seem like the problem really is being able to know where all your orchestrators are, in relation to the master node. It's really being able to figure out where that request is coming from, because right now it's easy because we know everything is coming from a few IP addresses that are Livepeer Studio for the most part. It becomes a big issue if the network opens up and it's, you're getting fresh new requests from all over the place that you need to then and pull everything again in real time or real-ish time.
That's also one of the things, like if at the point where you scale, the master node becomes a bottleneck.
Yeah. Well, like any node can be the master, right? You can ping any one of the nodes. So you could do some sort of geo graphical things where they say, okay, well, if you're in this area, you can go to the nearest router. But that router wants to identify the absolute best orchestrator to send you to, right? And the best orchestrator is probably going to be the fastest or the closest. And so if you have broadcasters originating from areas that you have no idea where they'll come from, then you're going to want to set up a system where just using the Livepeer router, so it can be open source and just within our own network, a way to identify which orchestrator it should go to.
And I think using proximity does kind of take out some of the unknowns and solve for it. But, just back to our original issue was, I think what we saw yesterday was that some broadcasters might block ICMP ping. And we were trying to, find a port that the broadcaster could be checked on, because the routers were essentially, all the routers were trying to ping to that broadcaster to see how fast it was and report back.
Yeah, this is a significant issue we ran into that we were wondering if is going to be a killer of this of the ping idea, was that a number of the broadcasters were not willing to return a response. So there's absolutely no way any of the routers, they would all just come back 0 milliseconds because it timed out or it just got rejected. So there was no way for the router to determine which one was closest.
Yeah, like the difference is today when a broadcaster is trying to decide what the fastest orchestrator is, it has a defined port and an endpoint that it checks an API to get details, and it counts how much time it takes for it to respond back. So that's all pretty regulated, but when it comes to the router trying to ping back to the broadcaster isn't expected to have any ports open necessarily, and they could be blocking pings or any kind of thing. So that's where that got a little unknown, and like you said, the performance was probably a bit unpredictable. It probably works good when it's cached, but if it ever has to refresh, it should probably do the refreshing, any way that it could, like
as a sub
on
process,
a more casual basis. Yeah, a separate process so during the initial.
Yeah, once I was thinking of this, and I thought, well, once once a broadcaster sends their ping and we cache that IP address, we now know that's a known broadcaster. We don't have to wait for them to get an orchestrator request for us to update the router caching. We can do that just as a sub process whenever we want. So once we discover the broadcaster, we never should have to add latency. We should just always have a cached version of who's the closest. You're right. We should never ever have to wait for the selection process to happen during the beginning of a stream, right? It seems like a bad time to be doing it.
Yeah, you could just go ahead and return whichever IP happens to be the main one at that point.
Every 5 minutes, you could just ask every router to ping every broadcaster and just update the results.
Yeah.
And then because like you were saying, Mamood, because then when an orchestrator hits the master, it's just always going to get a cached response, which is going to be so much faster. And I'm trying, so that is actually architecturally something we should probably do if Brad is here listening, is the updating of the caching information should not be we shouldn't wait until they ping us again. We should just do it periodically. But then the question but then now we're going to go deeper, and this is why I wanted to bring this up, was because is ping distant latency the right metric to be determining what is the best orchestrator? It seems pretty good. I mean, it's pretty like if you're in the wrong, if there's a significant difference in distance, it's usually pretty obvious in the latency. And these are highly available commercial nodes, so it's not like usually
So I think we need to agree that there is no like absolute best, and no, it will not be the best in all cases. So that's for sure. Like, let's say if someone is living on, like, I don't know, the Mediterranean Sea in Egypt, which has like some of the fastest intercontinental cables, and does a ping to London, it will probably be faster than, I don't know, like a country nearby. But that, again, that's part of the things that we just cannot anticipate, which is why I'm saying empirically the proximity is a good enough indicator. It's not going to guarantee optimal solution every time, but it should be a good enough mechanism. What we need to have in place is a timeout mechanism and a fallback mechanism. So a timeout is, sorry, go ahead.
Okay. One thing, when you mentioned that say you have a bigger pipe that goes to London, wouldn't you want, for live streaming video, wouldn't you want the bigger pipe, the fastest, even if it's farther?
You would. You will have to sacrifice against something else. So obviously, it would be great to have the best latency all the time, but there's just no way to really do this at scale. Like even if you ping, you wouldn't be guarantee. Maybe you can say, okay, I'll ping 10 times, and then if it turns out that the one in London is the fastest, then I'm just going to use that one. But then pinging 10 times is going to be too much time. And again, it's not going to be an absolute guarantee. It's good probably if you ping it like a few times and it's still the fastest, then yes, that is the fastest. If you ping it once or twice, then maybe it's not the fastest. So it's, again, it will always be like a guesstimate kind of thing. So the question is, do you want to have that, or do you want to say, like, another approach could be that you just do like a minimum latency thing, like whatever responds under, like, I don't know, 200 milliseconds. I'm just gonna pick the first one that responds under 200 milliseconds. You can also do that, but again, though, like, there is no solution that I know of that would guarantee absolute optimal response all the time.
Right. But
I think we all agree on that, and that's acceptable. I mean, you can only do, you're going to hopefully get the best result, and it's not going to be perfect. But the issue is really on the other end.
Let me explain to you where I am at currently. So I'll explain how bad the situation is. So right now, the master of my Route 53 with Amazon, my master, like my GeoDNS, is New York. So if you send a request from Africa, middle of Africa, it won't go anywhere else but New York, because I don't have any good geolocation rules in that area. Because otherwise I have to go through every single country and pick what node it should go to. And so the problem is Eastern Canada and Western Canada are one country, but I'm only allowed to pick one area that it can go to, right? But if something originates from Vancouver, I don't want it going to New York. I want it going to LA. But I can't with those rules because they're so strict. So right now, I have all my geo rules set up only around one broadcaster, and that's Livepeer Inc. I'm trying to make it so that if any broadcaster comes on the network, I can provide a good enough solution that they can find a close router or a close node, right? And this and while also trying to build an open decentral or an open sourced solution that doesn't require on a third party. So right now the solution is latency, which isn't great, but it will almost always work if it's transcontinental, right? You'll see the difference.
Okay, so what's the problem?
No. I'm getting feedback. Because this is the path we're going down, and I'm wondering if there's a better path. And it seems like there's lots of trade-offs. But
yeah, exactly. I think the latency. The problem is to identify the latency. It's not going to be that trivial all the time. Like, it will still be an estimate.
Right.
Yeah, I mean, once you hit the O, there's a lot of other things that can run slow. Even just the transcode itself.
And also sometimes there are other conditions that you probably haven't seen yet, which are things like network corruption. Like, there might be a place where the internet is fast, but there is a lot of corrupted packets. And that would trigger a retry, which will slow down your response. And again, you wouldn't be able to know that because at the beginning. You might try to determine some form of like high-level mapping, but it will not be accurate. I have seen this actually quite a lot when I was working at Amazon. There's often the case where there would be a high network corruption in India, and we would always have to like play around with some network tweaks just to make sure that the packet arrives intact. But the problem is every time we try to ensure that, the whole thing slows down. So the buffering rate increases, the whole thing slows down. And yeah, it's the nature of the problem.
How dare you identify the nature of the problem to me? I know. How dare you? I'm looking for a simple, fast solution. Damn it, Mamood. How dare you?
No, the thing is, I actually used to teach distributed networks back in the time in Germany, but I know there is actually like 7 rules on how to design distributed network applications, And a few of them is like you cannot have any guarantees on latency, you cannot have any guarantees on receiving the thing. There are like a lot of things that are just part of the nature of designing such a system. And the right thing which you have identified is what is the right trade-off for my particular use case. So you always say the best, the absolute best. I think that is the wrong way to think about it. You shouldn't think about the absolute best. You should think what is good enough.
You're going to end up in the ban channel soon. Keep talking like that. No.
And just so basically, there has to really kind of be two different scenarios. One is if it's a known broadcaster that you've worked with before, you know where they are, and you don't have to run all this stuff. But when it's a new, fresh broadcaster, that's when all the pinging's got to happen, and that's where I think a lot of the good enough stuff comes into more play of like, hey, did it respond within 100 milliseconds or whatever you want to cut off? Just go with that, because otherwise you're going to start getting some seriously long delays for fresh new broadcasters.
Yeah, I think if we could put it in almost like in a queue to have the router check at a later time, and on the first request, maybe let them just use the main one. That, you know, assuming that the router, I think in the router and the O are assumed to be on the same system, and they don't necessarily. But let's just say we just use the first of them, or the master, orchestrator.
Or maybe it's a combination of things where, you know, the broadcaster gets a request from the master router. The master router obviously caches that address, and then periodically, every 5 minutes, we create a process that determines what the best one is, and that doesn't have to be just latency. It could be maybe a measured approach where we include latency, we include proximity, we include like an algorithm that maybe takes into account multiple factors, and then that can be cached as the best place. So back to Mamood's part, you're not relying on one thing. Maybe you send 10 pings, you look up the IP address location. Okay, is it within proximity? You could even do things like, okay, what country is it in? Are we going to have, you can even have manual overrides. Maybe it's more of an algorithm that you can manage at that point. And then the routers would just cache the actual response. And then from a network side, most broadcasters, I mean, 99% of the GET requests are from the same 7 Livepeer Inc. broadcasters. So we don't need to do...
They are now. They are now.
They are now.
Hopefully,
but
hopefully they won't be.
In the future, they probably won't be. But what you could do is, once you discover a broadcaster, that broadcaster doesn't change very often. Like, it's not like a public network where it's coming in from all types of computers. This is a broadcaster node is a pretty well-established node. So once you run algorithm on there every 5-10 minutes of making sure that it's going to the right place, you could take into maybe multiple things, which would maybe make it more reliable, like Mamood was saying, where it's not just one thing, but maybe it could be a multitude of things, right?
Yeah, your preliminary check could just be that proximity, which shouldn't take time at all. And then, like you said, more of a combination on the back end, in the background, to validate. Sounds like a pretty healthy balance.
Probably does. It definitely makes sense to not have to be rerunning that algorithm every time a new GET orchestrator response comes in. That should be done in the background so that we don't need to keep running that request at all.
That shouldn't be happening at the time of the GET of the request. I mean, it shouldn't be. I mean, because you're going to get. I mean, your response time is going to be slowed down. I mean, dramatically versus having that cached.
Yeah, well, and that what was happening was Sao Paulo. The timeout was 2.5 seconds. Sao Paulo just like wouldn't reply, or it was just taking forever, or maybe the router was down and it was asking the router, but it was just down. So after 2.5 seconds, it would finally return the response. But if you could imagine, somebody returns a response in 8 milliseconds, and the other one's 2.5. I'm not sure what
that was my other question. Is I know it used to be where Livepeer, when they would send out a request, it was like it would take like either the first like 8 or 10 that responded to it. I think that's been changed, but does anyone here know, or can anyone here maybe take a look in the code and see, is that's like what is the actual way it works now? Because then I heard it was like, okay, anything that responds within a second is eligible for the work.
You have to ask Brad.
So I don't know where
but I believe Brad looked at it, and it's
okay.
anyone who responds within 4 seconds
is eligible.
Yeah.
And then it goes to the stake weighted, and then does like the 30%
well, no, it does
random,
performance weighted. So I think it goes something like anyone who responds within 4 seconds, okay, you're in this list. Now it goes back to who has a previous cached performance.
Oh, so trusted. I think that's considered a trusted orchestrator, maybe.
Yeah, I don't know what.
Or go ahead.
The
Sorry, I don't
verified
want to
thing.
interrupt.
But I believe it goes. Then it goes. Okay, who has a performance, a cached performance score from a previous stream? Okay, now of those people, who was the fastest? Okay, I don't. Or no. See, this is where they were changing things. It used to say if you were below real time, then it went to a stake weighted solution. But they are saying now that they're going to take into performance as a metric. So, which kind of really screws over pools a bit, because pools are going to have more problem than this than O plus T's. So, but that's a whole interesting different conversation about the selection algorithm for things. But right now, I believe if you're under real time, then it just goes to a stake weighted selection.
And there's no limit to how many people are in that pool or into that group. It's just based on if you're fast enough to make the group.
Yeah. So the theory was if the timeout was 2.5 seconds, then you would still get into the selection group within 4 seconds. And then from there, you would get choosed based on your good performance. So therefore, that's what we were assuming. But it has not been working that way. So, yeah. Go figure.
I do know
that definitely make sure that you know exactly how it's doing the selection right now. Like, because if you're gearing it up for something that's not, I mean, I'm not saying you're not doing it right, but I just know that stuff's changed around a bit. So wanted to make sure you're working.
What's super confusing though is that a bunch of it seems sporadic, and out of 42 broadcaster nodes that would ping the master router, 7 of them came back as rejecting the ping, the IMCP ping. So they were just going to the master router would pick itself on default. So if there might have been a closer orchestrator, but the router couldn't identify it, so the router would just give it itself. So that then is there a bunch of performance loss because the routers couldn't actually. So that was another problem, was if the broadcasters don't accept a ping response, then the router doesn't really work too effectively.
Oh, and you were finding that's frequently the case.
Well, what are the reasons for the failed test streams, or the suboptimal test streams? Is it because the router couldn't, it's picking New York when it's in Singapore, or is it because it's not returning the broadcaster request, the get orchestrator request fast enough, right? Like I don't actually know where the problem is. So beyond the selection algorithm of who's closest, I'm trying to figure out if this is even, but if it's cached, then it won't have this problem of. So I'm trying to fix one problem at a time as we build this. So if I can just switch it to a fully cached system, does that get rid of the need? Because it'll return an orchestrator response within always 200 milliseconds, even if it comes from Singapore. Singapore hits New York, that's 200 milliseconds, and boom, it's already got the orchestrator information. So now you're competitive again with everyone else, right?
Yeah, I
the,
think when we
the only thing you need to account for is that there will be situations where the time between the ping and receiving a request, something might have changed in the situation of the network. Like, for example, an orchestrator going out. And in that case, you need to have a fail-safe mechanism. Like the broadcaster should be able to like go to another one.
Right. If your orchestrator goes down.
Yeah, like, because again, you're gonna do a periodic like background check, but then at some point someone restarts their node, so you don't necessarily always have the latest. So at that point, the broadcaster should be able to request or to fall back to another orchestrator.
Well, if an orchestrator goes down while the broadcaster's streaming with them, they just boot them altogether from their selection. If the broadcaster is requesting a new get orchestrator request, the router would have to know that that orchestrator is down, which would have to be like a background process.
Yeah.
But at that point, I just give up because there's 100 other orchestrators on the network. I'll just give that work away.
That's where the Livepeer like takes over. And
yeah,
just,
that's like I'm not too worried about routing my Singapore work to Frankfurt just to be sub real time. Like that doesn't help me. That doesn't help anybody. Like if my Singapore node is down, like please don't choose me. Like there's no good alternative.
Mm-hmm.
So I wouldn't even prioritize that. That's the Livepeer network's job, which is like.
But here's the difference. So there might be a situation where if you have a cached response, the node might already be down. So it's not that it's gonna fail midstream. It's not gonna be able to even establish a connection because the node went down since the last time you pinged the node.
Right.
And in that case, I don't know what would be the path, but it could try and request, or when you are sending, you can send it like a list of orchestrators in like a priority order or something.
No, because the broadcaster requests each orchestrator, and over half the orchestrators come back with no response, right? Like most orchestrators are not actually transcoding. They're just just chilling on the network, generating stake. So so those you just end up in that pile of people that don't reply, and that's it.
Okay.
The broadcaster would then choose the orchestrator with the fastest response and blah 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 and move on from there. As an orchestrator, if your orchestrator node is down, like you need to work on getting it up and let the Livepeer network just pick a different orchestrator at that point.
Okay.
Yeah.
I think the other thing I wanted to call out, because I gotta drop in 3 minutes, but one thing, and maybe it's a curveball, but it's something that I think is worth considering, is when you're choosing a node, your criteria might be different whether this is an on-demand stream or a live stream. So with a live stream, you could argue that it's more important to reduce the latency, but with an on-demand stream, you might, for example, want like a more reliable node. And if you have that, like again, periodic mapping of, let's say there is an orchestrator node that responded like 95% of the pings successfully, but it's not always the fastest, but another one has the fastest response, even though it's not as reliable. With live, you might decide to go with the faster one, but with on-demand, you might decide to go with a more reliable one. For example, like that's just an example.
Yeah, so that can all be built into the router during the background sub process, because there's other things to consider too. If your live orchestrator that would handle a live stream very well only has capacity for like 20 sessions, and then you have this New York node that has a bajillion capacity, you would say, well, send the VOD work to the person with a lot more capacity because we're not too worried about real time, right? And so that can all be built into this router, which again is kind of like a middleware for helping direct traffic in the network, which I think is also going to be pretty critical. So again, this is why, yeah, this is the big, I mean, this is the first thing, this is the idea of this router. It routes work based on criteria, and as orchestrators, we get to control that. So. But yeah, and we've beat this thing to death. So I'm gonna move on from it because there's other topics. But anyway, I hope that was helpful for the people listening. And thank you, Mamood, for all the input.
No, it's a really interesting problem to solve, I think. And yeah, thanks for bringing it up. I think it's like what I would do is I actually experiment with a few of those approaches. Like it's really hard to say without trying them out. So yeah, I wouldn't overthink it too much.
Nah, I was just trying to get away from, I was just trying to fix the problem of Xenon sending me work, but I don't have anything set up around Xenon nodes. And I was like, well, I only am catering to Livepeer Inc. So I was like, how can I build something that caters to all broadcasters? And then, as you can see, this is a bit of a rabbit hole because now it's like, well, how reliable? Yeah, how reliable? How accurate? What are the features? It's like, whoa. Okay, let's just see if we can get work from broadcasters at least roughly to the right orchestrators. That's a good place to start.
Totally.
Cool. Okay. That was a lot larger topic than I was hoping. Well, not that I was hoping. It was actually really helpful because we've been spending a lot of time on this, and I think this is an overall pretty big benefit to the network if we get something like this running. Because I would hate to have a new broadcaster come in and have their their broadcaster node in the Philippines and then just like have really poor service because most of us are all basically catering to Livepeer Inc., right? Okay, let's move on to some other topics. Let's see what else we got on here. Mamood, I know you have to go, but you did mention your bubble integration and Flutter integration. Do you want to quickly explain what you were talking about there?
Yeah. So I was reading the other day that I think by 2024, like 64% or like more than 50% of the applications will be built by like no code tools. And I was trying Bubble to like experiment with an app, and I was like hoping to find Livepeer. I didn't. I found other plugins. So I thought, why don't we just build one? On one hand, it helps Livepeer tap into the maybe like the non-tech folks out there. And I think it's gonna be like a great add-on, even for me. Like sometimes I don't need to like customize Livepeer or anything. I just want to be able to upload and transcode from an app and be able to play with like a Livepeer playback ID. So feels like it's a bit easier, which is basically why I've been playing around with it. So far, I managed to get a plugin working. Like barely like a proof of concept thing, but it requires a little bit of work. So yeah, I applied for the grant. Let's see how it goes, and that's it really.
What languages are you using to build it?
So with Bubble, you use so they have actually like a no code thing for the plugin, but it also includes JavaScript. But it's not like a classic JavaScript. It's not like a product, like a JavaScript project that you build and then deploy somewhere. It's not that. They have a very specific way of defining what are the events, what are the actions, what is the state, and they define you like the specific functions with data encapsulated in objects that you need to handle and the life cycle of the events and stuff.
Oh, very cool.
But the language is JavaScript. Yeah, nothing too fancy.
And are you you're just integrating that into Livepeer Inc?
So I mean, so far I've just been trying to test it out. I don't know yet what Livepeer's take on it will be. Do they want it or not? So the way I'm thinking about it is, I would build a plugin and then open source the code, like make it a free plugin. And I don't know what is the way to do it for Livepeer. Like, do I just give everybody access, or do I keep it on a GitHub with an MIT license, or like?
Probably something like a GitHub with an MIT, but I guess the question is like, because Livepeer Inc. also supplies like the CDN and the storage option, whereas like we don't as broad. Like if you wanted to provide a like I could spin up a broadcaster node on all my nodes and then just say, okay, well I can allow ingest and outgoing of all my nodes, and I'll let you do it for free for a certain amount of minutes or whatever. But I don't supply storage or CDN on top of that, right? It's just, but I feel like Bubble would want that full and that the full stack solution, right?
That's what I was thinking.
Yeah. So whereas Livepeer Inc. already does like IPFS storage, and I think they do a pinning service, and then they also supply like their own CDN, which I don't know what it's through. I feel like it's through like Amazon or something.
Yeah, I think they're using Google Cloud, I think.
So, or if you wanted to build out that whole front end, I mean, you could use something like Media Network to do the CDN and then just store it on IPFS yourself, right? Just and then you could be the second broadcaster on the network,
That's an interesting. Yeah, I haven't thought about it that way, to be honest. But that's a very good call out.
Right, and then how they would pay for it? Well, you could just get them to deposit into the smart contract. Now, do you want them to connect wallet and have to deal with addresses and stuff? Like it's tough to how are they going to pay for this?
Yeah, I mean, my assumption was that I would actually ask them to like set up their stuff on Livepeer Studio, like get an API key and do all of those things and just plug it in the no-code plugin.
That's right.
But I wasn't planning to like do the whole thing unless Livepeer sees value in this and are willing to fund like more work into building like a full-fledged solution.
The way I see it, if you're targeting Web 2, just send them to Livepeer Inc. because they can, they don't care about decentralization and all these things. Whereas like if you're building something on top of Lens protocol, well, you want this decentralized NFT smart contract stack through and through, right? So you're going to be building these custom things for those kind of solutions.
Well, I think some Web 2 broadcasters do care about decentralization. I wouldn't write them off completely. Like Jarvis is a Web 2 broadcaster who cared massively about decentralization.
Yeah, well, that's true too, right? But I'm sure, is Jarvis okay with using Livepeer Inc? Like, I don't know if he'd be too worried, or is he just like so deep in the weeds that he's like, okay, I'm going to spin up a broadcaster node, I'm going to handle my own CDN, I'm going to handle my own storage. Like, that's pretty tough ask.
Well, they already have their own CDN, and pretty sure they're doing their storage. They just weren't comfortable with jumping in on Livepeer during the bear market.
That's right.
He was using Media Network, I think, for CDN. Yeah.
Does Media Network have their own broadcaster, or do they just use Livepeer Inc?
They don't. They're not affiliated, I thought.
They use Livepeer for their transcoding.
No,
I think it's an option, but I don't think that it does. I don't like if you just
it's all
go
peer-to-peer stuff. Yeah, it's not
Uh-oh.
Livepeer. They don't have Livepeer in their backend.
Oh, in their docs, they just say how to integrate Livepeer.
Yeah.
Right.
Which would be you stream into Livepeer and then it pops out into their CDN. There you go. Well, that's the whole question is, how we integrate these things. But anyway, yeah, well, I'm glad to see Bubbles coming along. You're working on it a little bit. It takes them, just a heads up, it takes them a long time to get back with approvals on grants, by the way.
How do you know how long normally it takes?
3 weeks to a month, maybe.
Okay, yeah.
The grants team is new now as well, so you might want to give them a bit of leeway.
Okay.
Or a bit of a kick in the butt too, maybe.
Yeah.
Bit of both.
Let's see. Regarding the previous topic, is there a place to like a sub thread on Discord or like a GitHub or a place where we can like track these discussions or add requests
For the router?
or like, yeah.
Yeah, it's under.
Is there like a place for us to talk about this or?
It's literally just Brad's GitHub, because he's the one that has the pull request or the branch, and I've been putting issues and stuff in there, so we've been discussing it. Or you can also hop into our. If you want, I'll invite you to our Discord channel.
Yeah, I mean, I don't know if I like how much I will be involved with it, but at least there are a few things that like I might be able to help with, or I might learn from the discussion. So yeah.
Sure. Here's the post. Okay, so I'll invite you to the channel, and then also the public GitHub repo with everything is right here. Okay, so it's in the chat here. That's Brad's GitHub where we're testing everything out. It's mostly, I mean, that's just issues on what I'm seeing in the logs, obviously. But yeah, I'll invite you to the channel. If anyone else wants an invite, let me know. Where we mostly talk about stuff. I don't know.
Sorry, I was on mute. Where are you guys doing this chat? I was side typing for a second. Sorry, I missed that. Where are you?
We're just in a chat. I can invite you if you'd like, Papa Bear.
Yeah, I would like to be.
It's kind of just like a. Oh, whoops! Create ad. There we go.
Thanks.
Yeah,
Chat. Now I get it. Thanks.
Sure. Here, let me invite to Authority as well.
Gracias.
There we go. Yeah, you guys just hang along for the ride. It gets pretty wild in here sometimes. Yeah. So just there we go. Okay, where am I clicking around here? Cool. Great. Any other topics to go through while we're here? We got Troy talking about the PFP image on the Explorer. I see he's gone. Basically, that's I don't know, the Explorer issue. We'll fix that with caching, hopefully. Speedy Bird, we talked about his topics around bots, the Telegram bot. Luckily, I think we answered all his questions in his introduction. So that was good. Mike Zuper talked about contract integration with other media networks. He's not here, but I think his was a pretty broad term on just how to generate more work on the Livepeer network. Transmental around VOD stuff. Oh yeah, that was the big conversation in the orchestrator chat that was going on. I woke up to this big long thread of people talking about what was it? VOD work, a lot of errors on the VOD side that he was showing. Anyone noticing that?
Yeah, they were seeing some instability. I mean, they're running a whole bunch of like custom stuff too, so I don't know what factor of that is just an issue on their end or Livepeer's end. I'm sure it's a mix of both. They were seeing some stuff that was a little odd.
Yeah, definitely. Well, there we go. That's all the topics, and we've been at this for an hour and 45. Even though it included me a lot of talking. Sorry, everyone, if I kind of took it up. I was trying to explain this whole router thing.
How dare you?
Yes, exactly. But a lot of people didn't have topics, so I'll take credit that yeah, I got some time. But I got a lot of feedback that was really helpful because the way we're going about it, I'm like, is this the right way? Like, it all started with the GitHub issue that Ben had posted, and you know, it was like, okay, do we go from the broadcaster? There's one thing I realized that just out of this conversation, that because Hunter said he really liked modularity, right? What you can pick in, you can, you know, pick and choose what you want, and it's not built into all one thing. During this conversation, I realized that, yeah, the router might be the good spot to do the VOD versus this live stream selection process of like, if a live stream comes in as VOD, you could say, well, I'll charge you this price per pixel and you can go to this orchestrator. Or if it comes in a live stream, you could say, well, I'll charge you this price per pixel and I'll send you to this one, right? So I think a lot of that can be done on the router side as well. You know, some
Yeah, definitely.
sort of balancing of stuff. I mean, that's pretty intense, and it would have to. There'd have to be a need for it.
That router is going to start getting pretty fancy. Start doing a lot of stuff.
Well, yeah, I mean, that's just the problem is that, you know, let's start with feature, you know, feature like some baseline stuff before we start adding too many features, right? But the router, I could see this being a nice little middle piece for like extra customability for orchestrators, which I've just discovered that today. So I'm glad that it's its own thing, because it doesn't affect people that just want to run, you know, standalone orchestrators, or it doesn't affect the broadcaster, right? So, yeah, I think it's a fun little thing. All right. Any other questions or topics?
Just to follow up. So, did you say you were finding that a good number of the broadcasters you said did not respond to pings that you were actually receiving work from?
It was only 4 out of. Okay, so here's some statistics. If you go in that chat, I don't know if you can see the previous chat, but it goes way up. But I'm sure you don't want to read through it all. Okay, so here are the stats.
It is there, but I'm if you wait for me to read that right now, I might as well just do it offline because
no. Trust me, you don't.
Yeah.
You can go back and read all you want, but this is going to take you a while. Okay, here are the stats.
Yeah.
In a week or two of running, 41 IP addresses sent get orchestrator requests. So out of 7, you know, it's the 7 orchestrator or broadcaster nodes with Livepeer Inc. I don't know. Well, yeah. Anyway, this 41 addresses sent get orchestrator requests. Okay. Out of 41, 7 of them were denying IMCP pings.
Yeah.
So
okay,
about 25% of these addresses. Now, of the 7 that were rejecting, 2 were Livepeer Inc. dashboard, the Explorer in Ashburn. So they were the dashboard.
The Explorer was.
Yes, the Explorer sends pings.
Okay. Okay.
If you didn't know, because it needs to update its price per pixel.
Know.
Right.
Okay. Yeah, I never thought about it, but yeah, it makes sense.
So the 2 of them were orchestrator. They weren't orchestrators. They were the Livepeer Inc. servers in Ashburn whose port 1935 was not open, so they were not receiving stream. So I'm assuming that's the Livepeer Inc. Explorer. 4 of them were 4 of them were broadcasters with port 1935 open. So they were clearly broadcasters because they're receiving. That port's only going to be open if it's a broadcaster, and they were denying ping requests, so I could not ping them.
Okay.
The last one was Marco, and we discovered this somehow because it was out of Las Vegas, and its port was not open.
Good way to figure it out.
Yeah, the port was not open. It was in Las Vegas, and it was blocking all my pings. And so I was like, and then I think Brad figured out it was Marco. So yeah, so that's where we're at.
Okay, the reason I was asking is because I keep a pretty I mean the best I can list of all the known Livepeer IP addresses, and I just started going through and I started just seeing which ones responded to pings, and then I was like, I don't even know if maybe some of these have been taken offline. But if you're actually receiving active requests from them, then I'm going to assume that obviously they're up and running. I just but yeah, I mean, I only checked out a handful, and I got 5 out of 30 or so that I tested that came back with no that didn't respond to a ping.
Oh, is that right? Okay, yeah.
I was just doing it while we're chatting. I mean, I didn't go through them all, but I just checked them. Started at the top of my list and just started going down.
Oh, there you go. Yeah. So I listed the ones that don't respond to a ping in that chat. So you can
to see if they match up.
Yeah. Go ahead and match that up. I have to scroll up a bit, but
I could use a search.
Oh, there you go. Yeah. So yeah, So I don't know. I wonder how it's doing right now. The stream test results. Yeah, like New York. So I have it set up right now for New York, Toronto, London, Frankfurt. And Chicago looks perfect. New York looks perfect. London, I don't know what happened there. Yeah, see, it failed. London got bad requests. No orchestrator count, 10. And then Frankfurt as well, no orchestrator count. So I don't know why it's doing that. I can't tell if that's the router or if that's, yeah. So the router's not working as great as it could be with its pinging setup. Yeah. I think I need to make it so that it doesn't re-ask every time. It just does it in the background. So yeah, my next test is I'm going to set the timeout, the caching timeout to whatever, 3 weeks, and so that it only does it. It only ever tests the router once, and then it just caches it. And so, can I get it to act to work really well with just the cached info, right? Because I'm wondering if broadcasters are getting confused when the on-chain URI is different than the get orchestrator response that it gets from the router, right? I'm wondering if this is just actually something that just won't work, right? Like midstream, if it loses connectivity, does it just automatically send a stream to the service URI? Because that won't work, right? So anyway, these are just
I don't know,
because it's intercepting the get orchestrator request and then giving it an entirely different IP address, right? Like it's going to New York and saying, okay, give me your info, and then it's going, here's my info, I'm actually in Frankfurt, and then it's like, thanks, and then it just starts sending streams to Frankfurt, right? It doesn't do another get orchestrator request.
Yeah, I mean,
so
yeah, that makes sense.
Will it actually work, or is it gonna like freak out?
I guess we're gonna find out.
Yeah. Anyway, that's about that. Any last topics, comments, questions, anyone? No, I think that's pretty good. I think we covered.
I'm good over here. I don't know. I'm not looking at the chat now, so I don't know who's left in there. But yeah, I'm good.
Cool.
All right, there we go. Yeah, we still got a few people left.
All right. Well, might as well end it there. Thank you everyone for coming to this week's Water Cooler Chat, where we talked about all things Livepeer. And great to have you. Thanks for coming. Next week is the 13th. I believe. I think I'll be around. I think I'm around. I might not be around. What day do I leave? I may be busy. I don't know yet. So I may ask someone to step in. But
looks like I may be hosting next week.
yeah. Papa Bear, if you want to step up, I might be on a plane. I'm heading back to Canada. So
obviously, just let me know if you want me to.
And the flight path is pretty long. So if I'm on the plane, I'll let you know. Or well, I'll find out soon enough. I don't think it'll be last minute. But yeah. Anyway, thank you all for coming, and we'll see you all next week. Cheers.
Thanks, guys.
Thanks, guys.
Thanks all.
Thank you. Bye.